All right, welcome to our next video. We'll be doing questions 8 through 12. I know it should have been 6 through 12 of the June 2015 Common Core Geometry Regents. Let's get this going. So in this one it says, in the diagram of the circle A, chords CD and EF intersect at G, and CE and FD are drawn. And so it's basically just describing this picture. Which statement is not always true? Well, this is all we have right here. We're not working with much. But you should remember from level 9, check this out, from level 9, and that unit was circles, that we have this one theorem, and that states this: if two angles, inscribed angles, intercept the same arc, then they are congruent. So two angles that intercept the same arc are congruent. Well, we actually have that situation here. Because if you look here, angle C and angle F both intercept the same arc. And that arc that they intercept is, well, for C, that's arc ED. If I draw this out, look at that. It intercepts this whole arc. And we could also say the same for F. F also intercepts the same exact arc. That intercepts ED, right? They intercept the same arc. So I know those two angles are congruent. But let's erase some of that for now. We also have another set of angles that intercept the same arc. Believe it or not, we have these angles right here, angle E and angle D. And those two angles both intercept arc CF. And I'll highlight this for you as well. Angle E intercepts CF, and angle D also intercepts the same exact arc, CF. So they must also be congruent. So we'll take that out. And so if you're looking really closely at this, the way I am right now, we actually know that we actually have two triangles right here. Triangle 1 and triangle 2. And these two triangles are similar because of AA similarity. Alright, so let's redraw these. Alright, let's just do a little redrawing right now and see if we can answer this question. So we have triangle GFD. I'm going to just pick these 3 points, and then I'm going to write the right corresponding angles to these points. So G corresponds with G in my other triangle, right? For F corresponds with C, we mark those as congruent, and E corresponds with D. Alright, and we have C is congruent to F, and E is congruent to D. Well, now let's see if we can answer these questions. So which one is not always true? Well, one, it tells me the triangles are similar, and we already proved this is true because of angle-angle similarity. So let's get this out of here. This is angle-angle similarity. We know that's true. We also proved the angle CEG is congruent to FDG. And CEG is right here. That's this angle. And FDG is right here. Remember, they intercept the same arc. So this one's also out. We proved this. They intercept the same arc. And now we're down to these last two. This one says the ratio of CE to EG is the same as the ratio of FD to DG. And if you notice, that's also true because CE does correspond to FD and EG corresponds to DG. These are similar triangles. The ratios of those sides will be the same. The only thing we don't know is true is this one, number 1, that CG is congruent to FG. And the reason I don't know that is because I didn't prove the triangles are congruent. I proved they were similar, right? So the triangles are proven similar, are not congruent, or at least we don't know they're congruent. So that's why it's answer number 1. We do not know this statement to be true. We didn't mark it. We just know they're similar, and we have these 3 facts that are true. All right, which equation represents a line that is perpendicular to the represented line? All right, so this we'll just first put into y equals mx plus b form. By the way, this is level 7, coordinate geo. All right. So we got 2x minus y is equal to 7. God, this handwriting is just terrible. I really would. Here, I'm going to just do this. Ugh. 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 Don't like it. Let's try this again. I want to do this all fish-like. All right. So we're going to do 2x minus y is equal to 7. Now to solve for y and put this into slope-intercept form, we're going to subtract 2x from both sides. We bring down negative y. Don't forget to bring that negative with it, and we get negative 2x plus 7. Now we're going to divide everything by negative 1 because we need y to be positive, and we got y is equal to positive 2x minus 7. Now, as I always said, if you get a whole number, drop a 1 under it. It's going to make this problem a little bit easier. We want to find which one is perpendicular to the line represented by this. So our slope here is 2 over 1. The perpendicular slope is going to be negative 1 over 2, right? Because that's the negative reciprocal. Negative reciprocal. All right. So, which one has a slope of negative 1/2? Well, clearly that's 1. Now people are like, well, why is the y-intercept changed? Well, the y-intercept doesn't matter. The only thing you need to look at is the slope. You could ignore the y-intercepts. That's not going to tell you if they're perpendicular or not. You're just looking for a different line with a perpendicular slope, and that is number 1. All right, which regular polygon has a minimum rotation of 45 degrees that carries the polygon onto itself? There's a simple formula you got to know. This is from level 1. Transformations. All right, and the formula is this: for minimum rotation, to figure out the minimum rotation to rotate a regular figure so it maps onto itself, we use this: 360 over n. Okay, 360 divided by n. Ugh. All right, so we're just going to see which one we plug in and gives us 45, which means it's going to carry on to itself. So we have 8 for an octagon, 10 for a decagon, 6 for a hexagon, and 5 for a pentagon. Well, let's start with number 1. That's 8. So 360 divided by 8 is 45 degrees. Oh, look at that. We figured out the answer. Now, if you don't believe me, try the other ones. That's 360 divided by 10. That equals 36 degrees. That one's out. We could try 360 divided by 6, and that'll give us 60 degrees, so that one's out. And then we could try 360 divided by 5, and we get 72 degrees, so that one is out. Sure enough, the answer is number 1. So an octagon, every time you rotate it 45 degrees, it maps right onto itself. Easy, just 360 over n. That's the only formula you need to know for that one. Next one. Let's see. Let's do a little erasing. Let's get this all out of the way. It's getting a little ugly up in this piece. So we got 11 over here. Hold on, let me get this out of here. All right, for number 11. In the diagram below of ADC, we know EB is parallel to DC, AE is 9, ED is 5, and AB is 9.2. Now remember, if they tell you these two lines are parallel, then we know the two triangles, the smaller triangle, the bigger triangle, are similar, right? Corresponding angles are congruent when lines are parallel like that. So we know the two triangles are similar. And we also know we can use the side splitter theorem. So in this case, we could actually use this simple thing where we just go across like this. We could set up our ratios as so. We're going to do 9 is to 9.2 as 5 is to x. Now x is going to be BC, and that's not what the question's asked for. It's looking for AC. But what we're going to do is just add these two amounts together, and then we'll have our final answer. So we get 9x is equal to 9 times 9.2 times 5, which, let's see, that's 45 plus 1, 46. Divide both of these by 9. And we get x is equal to 5.3. Now, that is not our answer though, right? Because if x is equal to 5.3, that just goes right over here. Hold on. I'm going to, x is equal to 5.3. But to get the total, the whole length of AC, we're going to add these two amounts to get that together, and we get 14.3 as our final answer. All right. And this is from level 3, similarity. Dope. All right, and then number 12. In the scaling triangle ABC shown below, the measure of angle C is 90. Which equation is always true? Well, this is actually from level 6, trig. And there's 2 trig formulas that you should just kind of memorize that'll help you out. One is this. The sine of A is equal to the cosine of B. And that's only true if A and B are complementary or add up to 90. We'll use that language. A plus B must equal 90 degrees. And the other formula you have to know is this. The sine of A is equal to the cosine of 90 minus A, which is basically the same formula. These two you got to know. Sine of A equals cosine B, or sine A equals cosine of 90 minus A. Well, if we look around here, which one of these is the same? Boom, it's number 4. And we are done with this video. So, you're welcome for doing, well, I guess not you're welcome, but hopefully, understand questions 7 through 12 of the June 2015 Geometry Common Core Regents. Goodbye.